You've had the experience of trying to drag something on the screen to a place it didn't want to go. When you dropped it in its new location, it went back to where it came from. Usually it flicks back so fast you can hardly see it move, but in this lesson I'm going to show you what it's like to move an object that keeps drifting back to its home base no matter where you put it. This program adds another interface to the program from the previous lesson and instructs the object being dragged to return to its home location no matter where else it's put. The home location is in the center of the window. As you can see, another interface has been added. This time it's our old friend Runnable. We're going to need him to have the square automatically drift back to its home position. Now this is just about as crowded as it ever gets. It's pretty rare for a class to implement 3 or more interfaces. It's often 2, but usually just 1. Anyway, this is the new reference to the thread object. The X and Y home variables have been added to contain the home position of the draggable object. Here's something you may not have seen before. 2 assignment operators on the same line. You can have as many of these as you like in a row. The value on the far right is calculated and stored in the location to its left. Then that same value is again stored in another location further to the left. This example has only 2, but no matter how many there are, they all end up with the same value. This is not an applet, so there are no start and stop methods, so the thread object is created and started here in the constructor. The run method is just like the other run methods we've seen. It goes into a loop with a timer and calls repaint at regular intervals. The calls to repaint means there will be calls to update at regular intervals. If the size of the window has been changed, a new rectangle object is retrieved for it, and the X and Y location for home is redetermined, and of course an image object is created for the new size. Now this test is made to determine whether the square is currently being dragged. If so, this program doesn't mess with the location. However, if it's not being dragged and it's not sitting on its home position, the program inches it 1 pixel closer to home. The square no longer changes color while it's being dragged. And that's everything that's new in this program. The update method was already there, so it was almost trivial to make it runnable and add the thread object for animation. If the square is dragged off center, it works its way slowly back. If it's pulled completely outside of the window, it will make its way back into the window again and head for home. Reshaping the window moves the center, moves the home, and the square heads for it no matter what its previous current location.